is Lagos branch and Abuja branch. So each branch has its own network address as shown in the image. Lagos has an address of .1.0, Abuja has an address of .4.0, and we have like the connection between the two routers had its own separate network of .3.0. So since we've already covered it previously, I'm just going to connect them and try to explain what I'm doing. So the first thing I'm going to do is I'm going to just pull up all the devices we're going to use before I connect them. So to access the laptop as shown in the diagram, I come under end devices and I drag a laptop. So we need 3 of those. I'm going to drag 3 laptops. For the switches, which is what we have here between the router and the end device, we're going to need 2 switches. So the switches is located under network devices. I'm just going to drag the default switch by literally pulling from here. But besides that, we also have like other possible switches we can use. So we're going to need 2 switches and we're also going to need 2 routers. So I come over to routers under network devices and I drag the default router, one for Lagos, one for Abuja. So I'm just going to arrange them so that it looks like what we have in the diagram. Okay, so we have switch, router, laptop. So this for Lagos. Then for for Abuja we have router, switch, laptop. Okay, we also need a server. So to access the server, we come under end devices, and from the possible devices we have, you can see we have the server here. So in the question, it did not specify what type of server it was, but by default, it's going to be a web server. So we'll just go with the default. So the next thing I then want to do is I want to link up all the devices so that it looks like what we have in the diagram. And to link them up, we are going to use connections, the connections menu, and we're going to be using the copper straight through cable to link all the devices. So the way it's going to work is I'm going to select a port on my laptop, which is fast Ethernet 0. So we're using Ethernet for this connection, which is a wired form of communication. So fast Ethernet 0, and we link it up with any port on the switch. But I'm just going to go with the next available port to avoid confusion. So similarly, we repeat the same process, go with the fast Ethernet port on the laptop and connect it to the next available port on the switch. So the reason for this yellow dot or orange dot is trying to simulate the delay that occurs when you initially connect these devices. But if you want to like skip the delay or fast forward ahead, like with reference to the simulation time here, you can just hit the fast forward button. So I'm just going to connect this switch to the Lagos router here as well. So for this connection, I'm going to use like the gigabit Ethernet port because this interface is basically accepting traffic for the entire Lagos network. So we want to use a cable that has a higher bandwidth. So gigabit Ethernet has a higher bandwidth than the fast Ethernet port we used for the laptop to switch connection. So we're going to use gigabit Ethernet for the switch to the router connection. But since this is a simulation, it will not really have any significant implication since we are not dealing with real world traffic here. So it should still work even if you use fast Ethernet. So the next thing I'm then going to do is I'm going to repeat the connection on the Abuja side. So using the same copper straight through cable, I go with the first available Ethernet port on the switch and I connect it to the corresponding Ethernet port on the laptop. Same thing for the server. Next available port on the switch, connect it with the server port, which is just one. And for the switch to router connection, I use gigabit Ethernet for the same reason, and and I connect it to the corresponding gigabit Ethernet port on the router. So let me just get rid of this yellow dot. So that is gone. So we have red dots between the red arrows between the switch and the router. So those red arrows just indicate that those interfaces have not been activated. They are still down. But before we turn them up manually, I just want to assign static IP addresses to the Lagos branch and to the Abuja branch using the network addresses specified for both of them. So for the Lagos branch, the network address is 192.168.1.0. For the Abuja branch, network address is 192.168.4.0. So all the devices within the Lagos branch should have similar network portions for the IP address. So they should all start with 192.168.1, and the devices in Abuja branch should also start with 192.168.4. So what I'm going to do now is I'm going to assign a static IP address starting with laptop 0. So to assign the IP address, I come under the desktop menu, then I click on IP configuration. So we're going with the static option for now. So it's asking us for the IPv4 address we want to assign to this device. So since this network is a class C network, let me check if you mentioned it here. So the network is a class C network, and it has a subnet mask of 255.255.255.0. So the function of the subnet mask is just to distinguish the host portion from the network portion. So the address 192.168.1.0. Okay, I still have this, thank God. So this address is what we have for the IP address of the network for the Lagos branch and subnet mask of the network for the Lagos branch. So this is the corresponding binary value for the IP address for the network in the Lagos branch. And this is the corresponding binary value for the subnet mask. So the function of the subnet mask just distinguishes the host portion from the network portion. And the way it does that is all the 1 bit in the subnet mask, the corresponding bits in the IP address is going to represent the host portion. So for every place where we have 1 in the subnet mask, the corresponding bit in the IP address is going to represent the network portion of the address. While for the 0 bit represents the host portion. So this is just an octet. An octet is a group of 8 bits or a byte. So the first 3 octets for a class C network belongs to the network portion of the IP address. All the last 8 bits belong to the host portion. So that's what the subnet mask is used for. So by convention, the first usable IP address is usually assigned to the default gateway if there is one. So since this is a class C network and we know we have only 8 bits for the host portion as shown here, so we have a possible the number of possible addresses that we have within this network is 3 raised to the power 8, which is 256. But out of those 256 possible addresses, one is going to be reserved for the network portion, which is .0. It's always the first address, and the last one is going to be reserved for the broadcast address, which is .255. So the range then reduces from 192.168.1.0 to 192.168.1.255. The range now becomes 192.168.1.1 to 192.168.1.254. So that just represents the possible IP addresses that we can assign to devices within the Lagos branch. So like I mentioned, conventionally, the first address out of those usable addresses would go to the default gateway. So the default gateway is basically like the corresponding port on the router that can be used to like communicate with other devices in the network. So if we are trying to send a request that doesn't belong to the Lagos branch, it's not automatically going to be forwarded to the default gateway. And once the router receives it at the default gateway, it then passes it on to the other routers, which might lead us to where the destination device is located. So for the IP address, since .1.1 belongs to the default gateway, let me just go with .2 for the IP address of laptop 0. So this .2 is arbitrary as long as it falls within the range of .1.1, which has been taken already, to .1.254, then we shouldn't have any issues. But I'll just go with the next address to keep things simple. Then the subnet mask, since it is class C, is going to be 255.255.255.0, and the default gateway, like we mentioned before, 192.168.1.1. So we're going to repeat the similar process for the second laptop in the Lagos branch. So the only difference here will just be the IP address. We're going to be using the same subnet mask and the same default gateway, since they fall under the same local area network. So the same default gateway of .1.1. So we would do the same thing in the Abuja branch. So for the Abuja branch, we have one server and one laptop. So let's allocate an IP address to the server. So to do that, we click on server on the device itself, then we come under desktop, IP configuration. So we want to assign an IP address of 192.168.4.2 using the same logic from the Lagos side. Then subnet mask, same. And the default gateway, the first assignable address, in this case is going to be .4.1. So that's all for the server for now. We go on to the next laptop in the Abuja branch. So same idea. This is going to be 192.168.4.3. Subnet max 255.255.255.0. Default gateway 192.168.4.1. So that is it for like the end device configuration. So you have to configure the routers as well. So remember, for the Lagos branch, we specified a default gateway of 192.168.1.1. So we need to assign that IP address to a specific port on the router, because the whole point of the router is to be able to connect different networks together. So each port has its own IP address. It's not like an end device where the entire device has just one IP address. But the router, each port has its own IP address, because the function of the router is to connect two or more networks together. So to configure the IP address for the port associated with the Lagos branch, you can just hover over here to see the interface we're going to be using. So we're using the one that has like the red arrow that is closer to the router end. So that's gig 00, that's gigabit ethernet 0/0. So we click on the router, come under config, then click on gigabit ethernet 00. So the IP address you then specify here is going to be the IP address of the default gateway for the Lagos branch. So that's going to be 192.168.1.1, same subnet mask, and also you also have to turn on the router to activate that port. So you can see the port is being activated now. After the delay has passed, everything is going to turn green. So we'll repeat the same process for this Abuja router, but this time around, yeah, let me just verify the interface. It's still 0/0. So we come under 0/0, and this time it's going to be 192.168.4.1, since that's the default gateway for the Abuja branch. Then same subnet mask, and we turn on our router. So the final thing we have to do here is connect the two routers together. Remember, I said each interface or each port on the router is going to have like its own IP address. So for us to be able to communicate on the same for us to be able to communicate through the same interface on the routers, then these two ports, this space between these two routers, they have to be on the same network. They have to be on the same network for them to see each other, which was what he indicated in the diagram. And that network is going to be 192.168.3.0. So I'm going to use the same copper cable to connect this end of the Lagos router to this end of the Abuja router. So we have red dot again. So we have to configure that interface, the new interface we just added, which is 0/1. So we go under the Lagos router again. We go under the Lagos router again. Is the recording still going on, Kunle? Okay. Just wanted to be sure because I heard this sound and I was not sure if it was still going on. So we go under the okay. We go under Lagos. So we go under 0/1. And this time, since we don't have any host device to worry about, this is a router to router connection. There won't be any default gateway that we have to reset. So we can just assign the first address in this range to 192.168.3.1, same subnet mask, and we turn on that interface. So repeat the same thing for the second router, the Abuja router, 0/1, 192.168.3.2.255.255.255.0. Then we turn that on. So everything is green now. Um, but one final thing we have to do is we want to be able to like filter the um the traffic that each router is going to processing. So the way it is set up now, basically any traffic can flow through the router since they are both connected. Any traffic belonging to a different network can flow through the routers. But we don't want to be listening to everyone's traffic. We just want to focus on the traffic specifically from the Lagos branch. So what we want to do is for the Lagos branch, anytime the router, this router 0, let me just rename it to Lagos router. So anytime this Lagos router is receiving any traffic that has the network portion matching like the network address of our Lagos branch, which is 192.168.1.0, we want to accept that packet and pass it on to our switch for further processing. And at the same time, we know that the only way these two routers can communicate is if they are the two interfaces here are on the same network, which is .3.0. So basically, for the Lagos router, I want to accept traffic from any traffic destined for like 192.168.1.0 or 192.168.3.0. So the way we are going to do that is we are going to use the RIP protocol, that's router information protocol, I think. So we come under Lagos router and we under routing we'll see RIP. So we just add like the addresses where we want to be listening for traffic for. So if you want to listen for traffic from any traffic that is destined to the Lagos branch, then we specify 192.168.1.0. Then any traffic coming from the other router, which might still be heading for the Lagos branch, we also specify 192.168.3.0. So we also add that just the network address, not any specific host address. So we do the same thing for the Abuja router. So any traffic destined for the Abuja router, I mean for the devices on the Abuja branch, would have like a network portion of 192.168.4.0. So we want to accept those data packets to 192.168.4.0. And similarly, to be able to like ensure that these two routers can communicate with each other, we also want to accept traffic that is flowing from the Lagos router through this 192.168.3 address that is common to both routers. So we also add 192.168.3.0, and let's try and see if we can communicate with the devices. So the way I usually try to test mine is I try to ping the device itself then I ping another device within the network. So from, let's say, laptop 1, I try to ping laptop 0, then I ping the default gateway associated with the Lagos router. So if you can ping the default gateway, then it means that if there is a traffic destined for another network, then the default gateway should be able to forward it on our behalf. So if the ping request to the default gateway is successful, I then ping a device on a totally different network to verify the end-to-end connectivity. So let's start. Let's use laptop 0. So laptop 0 has an IP address of .1.2. So I'll try and ping itself. So that the command is just ping. But before we even go there, if you want to see the list of available commands, you can just type the question mark and hit enter or help. You get the same result. So this just gives you the available commands and like a short description of what they do. So we're using the ping, which just sends echo messages, just used to verify connectivity between two devices. So I'm going to try and ping the device itself, 192.168.1.2. So this should always work. So this always works. This TTL here represents number of routers like we have to come across before dropping the packet. So if we come across like 128 different routers and it happens that we have not yet arrived at our destination, then the packet is going to be dropped automatically and the request is going to time out. So what this ping command does, it just sends 4 ping requests to whatever IP address you specify. So in this case, all the 4 pings were successful. So we have 0% loss. All sent packets were received. So that's fine. The device can ping itself. So let's try and ping laptop 1. So laptop 1 has an IP address of .1.3. So we'll ping laptop 1 from laptop 0. So if that works, then we're good to go. So this works as well. So is the switch that is basically forwarding the request to the appropriate device since we're still within the same network. So the next thing I want to ping is the default gateway just to ensure it is working as expected. So let's use laptop 1 for this command prompt to access it. So ping default gateway of Lagos branch is 192.168.1.1. So we get a response. So since the default gateway is up and active, we should be able to ping other devices in a different network provided they've been configured properly. So from laptop 1, I'm going to try and ping laptop 2 in the Abuja branch. So they're in different branches. So laptop 2 has an address of .4.3. So this is going to be ping 192.168.4.3. And let's see what we have. So that works. The reason why the first one timed out was initially, since the request was coming from a different network, the switch did not know, like the Abuja switch did not know where to forward the request to. Because obviously the switch can see like the you can see the IP address that is assigned to the request, but it doesn't know which of these devices, like between the server and the laptop, the IP address belongs to. So what it does initially is that it sends the data to all the devices connected to the switch, except the incoming device or the incoming link. So if a device's IP address then matches the one that was sent in the packet, that device is going to indicate to the switch that the packet belongs to it essentially. So the next time the switch sees that same destination IP, then it stores the initial time it stores the mapping of the IP address to the MAC address. So that just basically, to avoid confusion, basically the switch just associates a specific port to the IP once it sees it the first time. So the next time the request comes in, then it knows where to forward it automatically, which is why the last three were successful and the first one timed out. So if I should try the same ping again, then all of them should work without any timing out, which is what we get. So let me try and ping the server in Abuja. So the server in Abuja has an IP address of just 4.2. So we should have a similar response as before. So that works as well. So if we send it again, everything should work as expected. So in the question, it did not really specify what type of server this thing is, the one in the Abuja branches. But by default, it's going to be a web server. So I guess it's safe to assume this is going to be a web server. So the web server has web pages that it can serve to the client. So to view the web pages, can just not to view to see a list of the web pages, you can just come here, click on the server, then come under services. So the first service shown is HTTP. So you can see both HTTP and HTTPS are automatically activated. And the server has the following pages: copyright, hello world, image, and index. And it also has an image file that can be accessed. So if we visit the IP address of the server from any of the client devices, we should be able to access these web pages or these resources here. So if I come on that desktop, let me check the IP address of the server, the 4.2. So let's go to laptop 0. And under desktop, let me close this. We come to web server. We come to web server. So if I were to type in just the IP address of the server, so I should be able to see the default page, which is index.html. Index.html, yeah. The default page is index.html. Even if it's specified explicitly, you'll still get the same result. And it's also possible that it might ask us to, I don't know, display something different on a web page if you want to tweak the question a bit. So it might be a good idea to know how to like modify the web page on the server. So you can just come under the services HTTP as before. You can either create a new file or you specify the name, and let me just specify again, maybe 1904080xx.html, since you are serving HTML pages. And we can type uh hello world, or what is expected is actual HTML. So you can type okay. To keep it simple, it doesn't have to be HTML. Let's just use a text file. So .txt, so we don't have to worry about HTML syntax. But I'm guessing it will specify what file format you want us to use. So let me save. Oh, so okay, it has to be HTML, PHP. Okay, so basically it has to be a language used on the web. So let's just use HTML since we'll see our results directly. So HTML, and we can just write an HTML element here. And let's say this is the landing page. This is just HTML. It has nothing to do with packet tracer. And we save. So it seems that's saved. I hope it's saved. Okay, it seems it's saved. Okay, that's saved now. So if I were to go to, let me use a different laptop now, laptop 2, and I type in the IP address of the server, which is under the browser, which is 192.168.4.2. Since I specified a different page other than index.html, I have to be explicit about the page I want to visit on the website. So I can just type in the IP address of the server followed by the page I want to visit, which is 190.4080. xx.html, enter. So, and we see this is our landing page. You can also decide to modify an existing page if you want. Come under http hello world. Okay, this should already read hello world. Let me just modify index html. What should I type here? So I can just type CPE528. Any valid HTML is fine. So computer networks. Save. Let's run access. Yes. So let's run access it now on a client. So if you don't specify any page by default, it goes to index.html, and I hit enter. So you can see what we typed. Computer network is being displayed on the server. So one other thing I wanted to that we also covered was DHCP, assigning IP addresses automatically using DHCP. But before we do that, let me just add some styling so that to resemble what we have in the image in the question. So let me create space here. Um, System is hanging. Okay. Okay. So to draw like a rectangle, I guess that's what it looks like. And just hover, you see a draw rectangle icon at the top here. It's going to ask you to select the outline color. The outline color just like the border color. So from the question, it already looks like it's black. So I'll go with that. And for the fill is more of the background color. So we need to change the fill color to match what we have in the question. So the closest color I can find is this guy, I guess. I'll go with him. And let's close. Let's try and draw here. Okay. So these are Lagos branch. So for the Abuja branch, we do something similar. The only difference is the fill color, which is this. Okay. So something like this. It's meant to cover the I want it to cover the server. Yeah. So that looks fine. So to type in text as well, besides the okay, this is not it. Is this it? Okay, yeah. So beside close to the draw rectangle icon, the next two icons to the left, you see the place note icon. So you just like tap where you want to type in the text, and you type in what you want to write. So this is going to be Lagos branch. Same thing for Abuja branch. We also specify um the address of the Lagos branch, which is 192.168.0. Same thing for Abuja. Uh, let me just okay. Let me go back. No. I'm trying to move this text box to where it is meant to be. Okay. So 192.168.4.0. But for the router to router connection, it has its own separate network of 192.168.3.0. That looks fine to me. Let me drag this a bit. Okay, so another way we could also assign IP addresses is could assign them dynamically using DHCP. So the difference between the manual method and the DHCP method, which is automatic, is the manual method for each device that you add to a network or you remove from a network. You always have to update the IP address manually, which can be very problematic if you are dealing with a large number of devices. But for DHCP, as long as you configure a DHCP server, then anytime a device is added to the network, it's going to be automatically assigned a new IP. And when the device is removed from the network, the IP address was holding will then be released for future use by any other device that wants to use it later on. So conventionally, normally you're meant to have like a server for specific purposes, right? So you can have you can use the same server for web, email, file, or DHCP services, but practically in the real world, people just use a server for a single purpose. So if you are going to be dealing with email, you have your email server, and you have another separate server for web, another server for DHCP, things like that. So even if one of the servers should go down, you should still be like able to um provide services with the other servers that are available, unlike when all the services are on a single server. But to keep things simple, I'm just going to use the same server for this Abuja case. So I'm going to use this server as my web server, which is already what it is, and as a DHCP server to assign IP addresses automatically. So to enable the DHCP service, when you click on the server, come under the services menu, you click on DHCP. So there are a couple of options here. So for this Abuja network, this is a server pool, this is a default name. You can change it if you want, but I'll just leave it as is. For the default gateway, we're going to be using the same default gateway of our Abuja branch, since that is where the server is located. So it's going to be 192.168.4.1. We're going to leave the DNS server as is because we didn't set up DNS services. So the start IP, okay, for the start IP, we have to remember that since this is a class C network, we have like 3 per 8, that's 256 possible addresses, out of which the first address, which is .0, is reserved for the network address, and the last address, .255, is reserved for the broadcast address. But in addition to that, we've also assigned .1, that's 192.168.4.1, as our default gateway. So we cannot use that address again. So the unused addresses that are still assignable to devices in the network range from 192.168.4.2 to 192.168.4.255. So a good starting IP would be 192.168.4.2. So that just represents the first available IP that the DHCP server can pick from. And the subnet mask is still going to be 255.255.255. So the maximum number of users, since we have 256 addresses possible initially minus 2, that's to account for network and broadcast address. That brings it down to 254. Then minus 1 again for the default gateway. That brings it down to 253. So ideally, the theoretical limit in this case would be 253, but we don't even have so many hosts, and we don't want our network to be congested with too many devices. So you can use a value that is well below that 253 value. So here I can just go with 20 or something. So once 20 devices join the network and they assign the IP addresses, any other device that joins after that will not be able to get a DHCP, will not be able to get an IP address via the DHCP server. Basically, they won't be able to connect to our network until another device leaves and their IP address now frees up. So that's just the idea. So we have our default gateway, DNS left as is, that IP, subnet mask, and we've set the maximum number. So we then save and turn on the server. So let's try and see if it works now. So from laptop 2, let's assign IP addresses automatically using DHCP. So under IP configuration, we switch from static to DHCP. So let's see what we get. So we still get the same IP because that's the next available IP address. So if I was to add another one, let me just quickly simulate that. So let's say I was to add a new end device PC, and I connect it with my copper straight through cable from here to here. So I'm just going to skip forward to get rid of this delay. So it has connected now. So if I click on the server, I shouldn't have to, if I click on the new PC I just added rather, I shouldn't have to manually assign IP address information again. I can just click on desktop, IP configuration, and just switch to DHCP. So that works as well. So that's the whole point of DHCP server. Just configure it once on the DHCP server, and the IP addresses would be assigned automatically. But for the Lagos branch, we might also have to, if we are going to be using DHCP there, we might have to use or configure another separate DHCP server. Because if you look at it, in the Abuja branch, we have a separate network address from the Lagos branch, and the Abuja branch is only assigning IP addresses that fall under the network portion of the um Abuja branch address, which is 192.168.4.2. So any address we assign from this DHCP server in Abuja is always going to have an address of 192.168.4.x, where x is the host portion. And since that is different from the network address in the Lagos branch, we would have to configure a separate DHCP server for the Lagos branch. So to go over that, you just come under end devices here, server, connect them using the um copper straight to cable, and let me just skip forward. So I click on the server. So what I want to do before I even configure the DHCP service, I want to assign a static IP address to the server, because the server's location should always be predictable. It shouldn't be changing, unlike clients that are requesting for IP address information. So the server's IP address should be fixed. So we're going to configure a fixed static IP of 192.168.1.2. So at this point, this currently clashes with the one we configured for laptop 0. It currently clashes with this, but we'll resolve that when we switch from static to DHCP IP assignment. So .1.2, since .1.1 has been reserved for the default gateway. So 192.168.1.1. DNS server is left as it is, since we are not using the DNS service for now. And the address is already using the network. We'll get back to that. We'll resolve that. So let me just make sure it's saved. Okay, we'll resolve that. So now we've configured a static IP address on server in Lagos. So we now want to enable the DHCP service. So we come under services menu, click on DHCP, and we use the same idea as the Abuja branch. So the default gateway is going to be the default gateway of the Lagos branch, which is 192.168.1.1. DNS server same as before. That IP. So the start IP is going to be from .3 this time around. Since .1 represents .1.0 represents the network address, .1.255 represents the broadcast address, .1.1 represents the default gateway, .1.2 in this case represents the static IP address on this server itself. So .1.2 is the server's own IP address. So we cannot use that in this case. So the next available IP address we can assign to our host would be .1.3. So I'm just going to change this to .1.3, and I'll cap the number of users that can connect to 20 like before. So this looks good to go. Let's save that saving, turn on the service, and let's try. So for laptop 0, we're going to switch from static to DHCP. So we've been automatically assigned an address of .1.4, and default gateway and subnet mask remains the same. So it's going to be reading the default gateway and subnet mask values from whatever was configured on the DHCP server. So if we were to do the same thing for laptop 1, we should get the next available IP, which should be .1.5. Let's switch over. Yeah, so .1.5. So that's basically it for what we covered during the tutorial. If there are any questions, you can just reach out to me on WhatsApp or something. So Kunle, I think that's about it. Do you get everything? All right, no worries. Good night.